This is the exercise for regularization using hotel customers dataset. Starting with our first question, what we have to do over here is we have to import the data and drop missing observation such as NN or null values. So firstly, what we will have to do is we'll have to read our hotel customers CSV file. So once we take our data in our data set, then we can perform various operations on it. So firstly, what we'll do is we will write this code. This code explains that dot read CSV function will read a CSV file named hotels customers.csv using pandas library read CSV function. The contents of the CSV file are loaded into a data frame named um, object named df, and on the next line over here we have to display all the columns. So this line sets an option in pandas to display all columns when printing the data frame. By setting data display dot max columns to none, it ensures that all columns are shown even if there are many columns in the dataset. Later on, df.shape prints the shape of the data frame as you can see over here. And to view few rows of the data frame, we are using .head function over here, which will help us to show few rows of our data set. Moving on to our next part of the code, as we can see over here, now we have to drop few missing observations. So we will use drop na function over here. This will help us to remove any rows with missing values such as NaN values. And over here, as you can see, in place equals true. This means that this is parameter which ensures that data frame is modified in place, meaning the changes are applied directly to df rather than creating a new data frame. And again, df.shape gives us shape of our data frame, and head prints out few rows of our dataset. This allows us to verify the changes made and see the updated shape and content of the data frame. In the next question, what we have to do is we have to encode categorical variables, that is, we have to create dummies. So for creating dummies, what we will do is we will write this line of code. So this line uses the pd.get dummies function. So it is function from pandas to convert categorical variables into dummy indicator variables. So df data frame is passed as the input to this function. Drop first equals true. This parameter is used to remove the first category of each categorical variable to avoid collinearity issues in the resulting dataset. The original categorical variables are dropped, and the encoded dummy variables are added to the data frame. So as you can see over here, we can't find a nationality column over here. So what's happening is we will get each variables of nationality as different columns, and it will be nationality will be prepended to the whatever variable we had, and each variable will have each different columns. So what get dummies does is it converts categorical variables into dummy indicator variables. Each variable is converted in as many variables as there are different values, like this over here. And columns in the output are each named after a value. If the input is data frame, as we have data frame over here, the name of the original variable is prepended to the value, like this. So there are a lot of those variables which are converted into columns over here, as you can see. Moving on to our next question. So looking at our third question, what we can figure out is we have to create a total revenue by adding lodging revenue and other revenue. So for doing that, what we have to do is we have to drop customers with zero revenue. So later on, we'll have to drop lodging revenue and other revenue as well. So firstly, what we will do is in this line of code, uh, we are creating a new column named rev, as you can see over here, rev in the data frame df. So what we are doing is the values in the rev column are obtained by adding corresponding values from lodging revenue and column and other revenue column. This step calculates the total revenue by combining the revenue from lodging and other sources. Later on, what we are doing over here is we have to drop customers with zero revenue. So this line creates a new data frame df1 by selecting only the rows from df where the values in the rev column is greater than 0. It effectively filters out the customers with zero revenue. After this, what we have to do is we have to drop lodging revenue and other revenue. So over here, what we are doing is this line drops the columns lodging revenue and other revenue from data frame df1. The drop function is used with axis equals 1 parameter to indicate that columns should be dropped rather than rows. So axis 1 is equal to 1 represents column wise. And later on over here, uh, to compute descriptive statistics for the rev column in the data frame df1, we are using dot describe function. It provides information such as count, mean, standard deviation, minimum quartiles, maximum quartiles of the rev function. This helps in understanding the statistical properties of the total revenue variable. As we have completed our task for this question, let's move on to our next question. In this question, what we have to do is we have to define y and x. We have to standardize numerical predictors, but we do not have to standardize categorical predictors. So firstly, what we will do is we will use dot describe function again over here. That will provide us a summary of statistical properties of numerical columns in the data frame df1. So as you can see, we are getting some statistics over here. This will be really helpful for us to figure out numerical columns in the data frame. So later on, we will distinguish x and y over here. So firstly, what we will do is these lines define the target variable y and the predictor variable x. The target variable y is assigned the values from rev column of the data frame df1. The predictor variables are obtained by dropping the rev column. As you can see over here, we are dropping the rev column from df1 using drop function, and we are using axis equals to 1 parameter indicating that column should be dropped. So x dot shape over here will print the shape of the data frame x, and second line displays first few rows of data frame x. So as you can see over here, we can see the shape, and later on over here we can view few rows of our data frame x. Now that we have defined our y and x, let's see how can we separate numerical and categorical predictors. So firstly, looking at numerical predictors, what we are doing over here is uh, these lines of the code will separate numerical predictors from data frame x, as you can see over here, and the variable x underscore num is assigned the columns from index 0 to 9. As you can see over here, 10 columns, and using ILOC indexer. So what's happening over here is this is our inclusive and this is our exclusive number. So we will include 0 and we will count 10 after it and we will consider it until then only. So 0 to 9 will be considered, and always the this number over here is exclusive. That's why we don't consider it. Therefore, we have got 0 to 9, which is 10 columns. So it creates a new data frame containing only the numerical predictors. The second line displays first few rows of x underscore num data frame, as you can see over here. Let's have a look at categorical predictors now. So just like before, what we are doing over here is the variable x underscore cat is assigned the columns from index 10 onwards, indicating all the remaining columns after the numerical predictors. It creates a new data frame containing only the categorical predictors. And over here, we are using dotted function to view few rows of our categorical predictors data frame. So leaving first 10 columns, we will able to see all the remaining columns over here. So let's see how we will standardize numerical predictors now. So firstly, what we will do is we will use standard scalar function. So what it does is it standardizes the numerical data, which involves scaling the values to have zero mean and unit variance. And later on, what we are doing over here is we are using dot fit transform. So it is used to fit the scalar to the data, which is x underscore num, and then transform it. So this is how we are able to standardize numerical predictors. Now let's see what is the type of our attribute x underscore num underscore std. So we can use type function over here to find that out. And as we can see over here, it is n dimensional array. So the type we are getting over here is numpy dot n dimensional array. So finally, what we will do is we will complete our task. So we were asked to standardized numerical predictors and not standardized categorical predictors. So at last we'll concatenate both of them. So therefore what we'll do is we'll use numpy.concatenate function over here to concatenate both the standardized numerical predictors and non-standardized categorical values. So this line of code will be used to perform this operation. Here concatenation between standardized numerical data and categorical data is performed along the columns, as we can see over here x is equals to 1. And to find out the type of the attribute x underscore std, we have used type function over here, and we got numpy dot n dimensional array as our type. Now let us have a look on what task do we have in our next question. So what we have to do over here is we have to run ridge regression using standardized predictors. We will do this using shrinkage parameter 1 to 200 using step size is equals to 10. What we'll have to do is we have to plot the estimated coefficients as a function of the shrinkage parameter. So let's have a look on a basic of range function and arange function. So basically what we can do is we can only use integers in range function, and we can also use floating numbers in arange function. So as we have seen before, uh, we can use start as inclusive, but we can't use stop as inclusive. It is always exclusive. And we can use step size over here if we want specific intervals between our selections. And talking about arange function, when we are using integer arguments, arange function is equivalent to range itself. Let's have a look on how we can perform these functions. So over here we can see arange function is used. So this line creates an array A using the arange function from NumPy. It starts from 1 and increments up by 10. As we can see, step size is equal to 10 over here, and it goes up to 200. So this will be the range of shrinkage parameter values for ridge regression. Later on, we can see over here is this M2 equals ridge function initializes an instance of ridge regression model M2 from scikit-learn and create an empty list coefficient to store the estimated coefficients for each shrinkage parameter. Now, what this loop is doing, we will have a look. A loop is started where each iteration performs following steps. This loop iterates over each value in the array A and sets the shrinkage parameter alpha of the M2 ridge model using setParams function, fits the model using standardized predictors x underscore std and target variable y, and then appends the estimated coefficients using dot append function to the coefficient list. And later on, dot shape function gives us a shape of the coefficient list, as we can see over here. Now let's see how we can plot a line plot over here. So using dot plot function, we can create a line plot where A represents x-axis values and coefficient represents y-axis values. Dot x label function use sets x axis label as alpha, and dot y label function uses ridge coefficient as y-axis label. The plot visualizes how the estimated coefficients change as the shrinkage parameter varies. So the magnitude of the coefficients decreases as penalty parameter increases.